this out. Okay. Fuse is good. Great. How am I going to test this now? I know. We'll build one. G'day and welcome back to the channel. Smash that like button if you like the intro there, and I'll know to do a bit more or know not to do a bit more. So yeah, I'm bereft a power supply unit, and yeah, I've had an inspection, and apart from a little something you'll see later on in the video, I couldn't find anything wrong with it. Fuse was fine as well, so yeah, don't know about that, but what are you gonna do? So I've decided to build my own, and for this I'm going to be using this fairly generic, it's a 240 AC to 24 volt DC 300 watt converter, and it's the WX-DC2440. And for the other part of it, I'm going to be using the XYH3606L Boost Buck Converter. And of course there are going to be some other parts involved with that, and see the link description below, but it's something like banana terminals, 3-pin plug point, you know, some wiring recycled from the old vacuum cleaner video. Check that out in the corner. I will also be doing a deeper dive than I've done before into the design process I used in Rhino to design the enclosure, which you will see as we get into the video. But before I get into the part testing, I just want to stress the dangers of messing around with mainline 240 or 120 volt AC electricity. It's shocking. Terrible pun, I know. But please, you know, don't do this at home, of course. And if you are ever messing with this kind of stuff, take care. Isolation is the key. Don't go wearing wedding rings. It's probably, well, it's not a wedding ring, that's a signet ring, but most common is wedding rings, and don't go wearing them when you're playing with electricity. It's probably a good idea. I've seen some horrible stuff. I actually have done a working in dangerous electrical environments course back in my past, when I worked with as a contractor for Energy Australia. Anyway, so yep, with all that out of the way, let's get into it. Now what I'm doing here is I'm testing out the AC-DC conversion unit. This is 24 volt up to 15 amps. So it's well above what I need to run this thing. And as you can see, I have tested this turns on and whatnot. This is wired up. I have no idea if this is meant to be neutral and live like this. There is no instructions I can find. Here is my plug. Here's where's the power's going to come from. This is switched off at the moment. There is a 10 amp fuse on that, on the live. The neutral just runs straight through. The earth goes to here, and I have checked that I have continuity between the board and the earth paddle, whatever you want to call it. On the output, I have here a voltmeter, much similar to this one here. That's just standing in for my temporary power supply there. And yes. Okay, so pardon the mess and the switching cameras. I've got to get a new top-down camera. So it's the moment of truth. It's time to plug this in and find out. Now, of course, this is going to be live, and you need to be extremely careful with live plugs. So, we'll put that in. and I'm going to switch it on. Okay, we have 23.9 volts on the gauge. Not making any noises or anything. Yeah, okay, cool, that seems good. Now the next thing to do, I've already tested this out, but turn that off. And as you can see here, I'll turn this on. And yeah, you can get some reflections. All right. So there you go. Okay, so I'm going to mock all this up now, and then I'm going to go to the computer with you, and I'll go through the case and how I designed that, and then we'll stick it all together, and hopefully I won't break anything in the meantime. So what I have done here is I have both my sketches. So these are the measurements that I took off and placed onto the sheet of paper that'll come up now. As you can see, I've got all my measurements there and notes and whatnot. And I've translated those into front view, side view, and the bottom, the back. And then I've created the objects. So I've gone to the ghosted view here, and you can see that this object here is the PSU, the Buck and Boost Converter. This is the AC to DC unit, the plug point, the Wi-Fi unit, on-off switch, fuse, and in this space here, the front here, will be where my terminals are. And that will pretty much be the device there. That's the size of the device and the layout I'm going to have it. And that's pretty much it. In the top here, I'm going to be putting a fan. I've got some sleeving for my wiring that runs up and down. So what I have to do now is figure out the way that I'm going to enclose it. I think I'm going to go for a base plate and front plate one piece, and maybe a rear plate as well, and then a side and top piece to go over the top. I should be able to include some space on either side of that and that and that and that. I'll screw it down here and here and here and here. What I'm probably going to do is end up splitting this up into surfaces and then joining the two surfaces out of that and build upon that. So copy that and put that into my backups later on. Explode this and grab the three sides I want. Join and join. Now I've got my two objects. So these are my internal dimensions. It's my internal box, so I have to build out from there. And then I think what I'm going to try to do, I am going to have to put those circles in, aren't I? Okay, first things I have to do is put in three holes for my, 3.5 millimeter holes for my terminals, and measure my terminals and space them out. Then I'm going to cut this highlighted shape here with the sort of split out the sections for these holes, front and back. And when I offset that surface post cutting out those holes, it will keep those holes in there, make the extrusions for me. I'll show you what I mean in a second. So let's try this out. Split by this. Okay, and now that offset surface. Now how thick do I want this surface? I want this surface to be distance equals, I could go for 3, might be a bit much, 2. And now I have this surface, and I'm sorry, I'm just messing up my mouse. I'm just going to copy and paste that and pull that away so you can see what I mean. So here, I already have my cutouts. And what I want to do now is probably add some support to these front and back plates. Start, well, I've got to put in those holes and whatnot, but that is basically what I'm going to do to get my plate, and then the top I will do something very similar. So I'm going to get all that done and come back when I'm much closer to having this designed. Okie dokie, right, well, here we are after a couple of hours of designing, and I've put my terminal points in and my vents,
and extruded out my base and top. As you can see the vents, as you can see the vents there are there in the side, and they're going to be either side of the AC/DC unit. And the fan will be at the top, and I think you're going to be sucking air in. Oh, I shall blow air. I've got some reinforcements in the corners on these and in the top, and I'm just putting in some tabs there and corresponding at the front to allow for the fastenings once the case is on. And all I have to do now is put in tabs at the front of these vents here and at the back here in the corners to close the top down in the corresponding positions here. Okay, so here it is with all the tabs on it. A little bit of mesh editing at the back, my strengthening, and there's the screw holes and the place for them to go, because it happened to be a bit high at the top, but anyway, whatever. Let's get on with printing this, and I'm going to be printing them both this way in this orientation, and this, 180 degrees, so that this top plane is the base, and we'll print upwards from that. And that's that. So I'm going to start printing and catch up when it's all done. So Mike from the future here, and what I have actually done is a bit of a noob error I should have been aware of. It was caused by not accounting for allowances in my design, and these are interfaced basically upon each other. This wall here, see with the cross there, that wall there, and the opposing surface, which is a lot larger and harder to see, are interfaced on each other with no gap. So what you actually want to do is come along and shrink this or expand this longitudinally in this axis here to account for that. Anyway, so what I'm going to do is in the next video I will come back to this and I'll touch on the design. As you can see here, I'm still doing a few, that's the Bluetooth module's dimensions, and that's its mount there. I'm still integrating these into the case here for part 2 of this video. So we'll come back to this and I'll show you how I fix up the fit problem, because I do want to put this on Thingiverse eventually. Anyway, back to the video.
There it is, 90 hours to print. 1.9 seconds to remove from the tray, from the plate. Alright, let's get on with some stuff.
One eternity later.
Right, so I've stripped out all the bizwas. That's all the bizwas. And now let's have a look at the wiring. Okie dokie, so here is the wiring for it in situ more or less, and I have somewhat reasonably cut the lengths for it. All this wiring here that you can see, this is all, apart from this, this black wire, this is all recycled from the vacuum cleaners I took apart. So it's the thicker wiring out of that. So what we've got here is mains coming in, and then we got neutral, earth down the bottom there, and your live, and the neutral blue wire is running in straight to the AC/DC 24 volt unit. And then down here you can see I have 2 red wires. That's going to be my live coming in. Live will go through to the fuse, from the fuse to the switch, from the switch to the AC/DC over here, and then back here is the earthing point for the AC/DC, and that will run straight up to the earth. And there is another orange wire here, so the earths are orange. I know that's not amazingly good, but it's the thickest recyclable wire I had around. And they will go down and to the terminal here, so they split parallel at the earth point and the terminal on the point there. The board is underneath the board. I have everything in a white sheath that was taken out of the vacuum cleaner too, so the wires are protected under there, and this is the thermostat running underneath there to monitor its temperature. from the AC/DC. The power comes out here into the Buck Boost Converter, and the Buck Boost Converter it comes out of and goes to the terminals at the front there. There's also the, better not drop it, Bluetooth unit, and that will be mounted up here on the top case, probably with double-sided tape. I have to integrate the case fan to the system, and if I can, I will piggyback it in parallel with this one here. I don't know if that's going to be possible. I don't even know if this is a 12-volt fan. So I have to find out the voltage coming out of this that's supplying it, and see if I can do a bit of research and find out if there's enough headroom to supply the current to run the other fan. Because if there isn't, I'm going to have to do a bit of a secondary project for this and make a tiny little Arduino temperature sensor to run a relay to turn the fan on and off. And I will power the fan off a hobby style buck converter. I think it's a 26 volt to 12 volt, so that should be fine for the 0.2 of an amp I need for the fan, which of course will be mounted in the top of the case up here. And that is pretty well all of that. If I have to do that, I will make the fan controller in a second video. I already actually have the code for that. I did that earlier on. I made a project for myself a while back when I was teaching myself Arduino and coding, which I'm still very amateurish at. Yeah, it was for my tent. It was like a fan control unit, like I said, and they would just cool the tent when the temperature gets too high in there, help keep it cool and less humid. So anyway, that is the project. I have to wire everything up and stick this on. So without further waffling on, get into it. Quickly, a word of warning before we go too far in. I wanted to point something out. There's something on that fan, isn't there? There's something that should not be on that fan, So where'd that fan come from? That fan was in the original power supply unit on the back. And I think it's highly probable that the same incident that caused that blobbing is what ended up stuffing the original power supply. I would imagine that it was just resting somewhere in there way too close, although I couldn't find it. If that's the quality control we're working with, then yeah. So that is something you really need to be careful of when you are working above electronics and around electronics. So soldering these terminals up here and here, you can have sputter that will come off and it could land on your circuitry and ruin your job. So what you want to do is remove the board, put it as far away as possible, cover it up, and then proceed to solder. It's just worth doing for those occasions where you get a blob that drips off, although you really shouldn't have that much solder on your iron. Anyway, right, let's get set up and put this all together. So these two and these two have to go into terminals, and what I've done is I've just put a bit of solder on the very tip of these both, and I've left this here. It's a tiny bit of solder's gone up there, but it's still going to bend, it's still going to be able to crunch. And because they're going into terminals, you actually want to have a bit of flexibility in the interface between the wire and the terminal, because it presses down on it and clamps, right? And if you've got a solid piece of solder, it's just going to be like you know, so imagine that's the connection. It comes down like that, it's just going to touch the top and the bottom. But if you have something that squishes, it's going to squish in, so imagine that way, and you're going to have all that contact surface both sides. So I'm going to do the same here, just quickly. So what you want to do is get your wires, twist them up, give them a nice tight twist. Nice tight twist. Don't knock them about when you're doing them. You knock one when you're doing the other one. And come along and just do a dab. Get a bit of solder on your tip. And just want to sort of dab the end. So that's going to give you a nice little dab. And keep them sturdy so they're not going to fall apart. You can just stick them in the terminals, but they'll still squish back here. And I hope that's helpful. Alright, so that's the wiring done there. Got the terminals for the AC/DC power. That comes all the way up here and back. And then the terminals wired up for the DC out. Ground's wired in. Got to put the units in. Put the whole case together. There's the top. And when it's done, looks up there. Oh. Damn, I was afraid I'd have to do that. I'm gonna have to do some fitting work. Yeah. Alright, well I'm gonna have to gently pry this apart. There you go. Alright, so I'm gonna have to do a little bit of work to the case. But the end effect is something like that. So I'm gonna get busy with the file and we'll come back and put it all together. Alright, so I've been over and I've filed the case, so pull that back, it's always good. Alright, and now I need to drill the holes 2.5mm here and 3mm here, because they have also been squished in. And as you can see, it fits fairly nicely, and once it's all secure, it'll be reasonably strong. So I'm just going to do this drilling here, and then it's back to putting it back together. Alrighty, so I've put the AC/DC unit back on, and as you can see I've put in the neutral wire there. And keep that well away from the ground. And now I want to put in my live. So you want to pull this back. And I'm just going to quickly, can you see that down in there? I hope you can. There's a little lip, so you've got to be careful when you're putting it in. But just pull it back, make sure you go in the hole, don't get caught on the lip in there, and then all the way down, and that's in there. So that is the AC wired up. So now, the DC. And I have to, this has to go, it's a bit jank. This has to go through here and to there. But first I have to put the terminal connections into here. So with these terminal connections, jam them in there. See that? And screw them down. That's that, they're in. So turn the unit the right way up, put the other wire through, and now you come in, and there it is. So that's in there, and as you can see those wires have decided to bunch themselves over that way. They want to be annoying, so I'm just going to coerce them a little this way. That's alright. Okay, so the final two to do, make sure they're nice and easy to get in. We have our negative. So I should have, this is where you want to solder tip them, because they become more difficult to maneuver. And screw them down. Sorry about the shadow. Check they're good and solid. Alright. So that, move that over there. That is more or less that. There's this little guy plugs in just up in here. See where the clip goes in the plug, and then that will get pushed underneath. And just a quick tip for the Bluetooth module. First of all, or not the Bluetooth module, for the Wi-Fi module, I think this will be a bind, you know, the Wi-Fi security bind button. And I think I'm going to quickly 3D print something to stick this to the top. Maybe just put a little hole on it. And try to find something just to go over it. Yeah. So it's all ready to go. Mains on. Of course, this will turn it on and off here, but I've left it on. Right, set to 5 volts there. To set the unit, click this once for volts, and then it takes you into it. Let's take this to go for a 14 volts, and then to start the power out, go on. I didn't even see it hit 14.1 then, that was pretty good. So if you go in there again, bit of overshoot when we get to 18. And there you go. And I'll just chuck on a light. So turn off the output. You can see it cascading down there. So, I'll take the voltmeter out of the equation. I've got this little light here. So our negative goes on here, positive on there. And we want to set it to down to 12 and start. And there you go. That seems to be working fine there. I think what I'm going to do is cut it here, assemble it, show you the finished product. Okay, so there you go. That's it. How about that? I'm just got to put all the screws in. I've got some there, and I stole the feet. So the feet and the fan, I stole from the old power supply unit that balked it on me. Join me next time, where we'll be going through the features of this little cool unit here, and I'll be wiring up the fan and installing the Bluetooth unit. And that'll be that. Once I've got everything together, I will try to make this available on Thingiverse. But bear with me, that might be a while. I'm having some problems with Thingiverse. I tried uploading the 3D printing files for the track crawler, and that didn't seem to go so well. I mean, it's all there, and if you go to my web to the web address I've put in on the description, it should go through, and it does seem to work. But if you go and look through my name on Thingiverse, it doesn't seem to come up, and there is a design there. So I'm just going to work on other things for the time being, and we'll get back to that. Alrighty, well, there you go. That is the first, well, I think it'll be the first long part of this little mini series. But for now, thanks for watching. I hope you enjoyed the video. Please like and subscribe if you did. It means a lot. Also, if you comment down below and let me know if you have any questions. I'm going to try to put this together, all the products and whatnot down below and on Thingiverse, but I'm having some problems with the Thingiverse account, so stay tuned for that. I'll give you an update in the second video. Be well out there, stay safe, catch you next time.